Hello friends, in this video lecture of CAD CAM, we'll discuss about geometrical modeling. In CAD CAM, we'll discuss about geometrical modeling. Now, if you talk about the geometrical modeling, these are of three different types. Number one is wireframe, and number two, surface modeling, wireframe modeling and surface modeling. Number three is solid modeling. Now, if you talk about the basic CAD system, we used to work on a software called AutoCAD, where all the components or sketches are made by using wireframe modeling only. Okay, wireframe model is not the complete representation of Now we'll have a discussion on complete. I'll give you an introduction about all the three: wireframe, surface and solid, and I'll start with the wireframe modeling. We'll have three different modules or three different lectures of wireframe is 1, surface is 2 and solid modeling. And in this particular lecture, I'll cover complete wireframe modeling, its applications, advantages, limitations, all other aspects of wireframe today we'll discuss in this lecture. In the upcoming lectures, we'll talk about surface and solid modeling also. I'll try to divide this into three different lectures. Okay. Now, if you talk about surface modeling, as I said, wireframe modeling, now this is not the complete representation of model, because here in this case, if you consider a 3D model, if I consider a wire, and start at a vertex point, a corner, if I try to wind it slowly, with respect to these edges, okay, the shape which I get ultimately, that is going to be the wireframe. It is not a solid one. Internally there won't be any mass or volume. Okay, now this is represented in the form of wires only. It is completely hollow inside. There is nothing inside. You could see from one side to the other, which is possible. So that is the reason I said this is not the complete representation. Okay, where you can't calculate inertia or mass properties of that particular component, which is made by using wireframe modeling. This is not possible. And one more important point to be noted here is, these are not possible. In a similar fashion, analysis can't be performed. The part can't be transferred or imported to any of the analysis software, and that can't be analyzed. Okay, that is one more problem. Okay, and here the thing is, in wireframe modeling, why we are using wireframe modeling? That is a question. When you have some problems working on wireframe model, still why it is under existence. Okay, small scale industries, they'll try to produce a drawing based on simple sketches. For example, if you want to manufacture a hexagonal nut or a bolt, a simple 2D sketch is enough with all the specifications. Okay, now here manipulation is possible. You can change the dimensions at any point of time irrespective of the shape of the component. That is also possible, whereas it is not possible with other softwares like SolidWorks or CATIA or ProE, where in case of SolidWorks, or for example in case of SolidWorks or CATIA or Creo or any other 3D modeling software, what you try to do is, you try to develop a sketch, and you try to transform that into a 3D model. For example, if this is your sketch, your model is supposed to be something like this, okay, in this thing. And after this, again you'll try to extract the views out of that particular component, top view, front view and side view of the, if I consider the front, top, left side view, if I will consider this as first angle projection. Okay, now we are drawing a sketch followed by a 3D model by adding a extrusion feature or any other feature. Then again we are extracting views out of this particular model. Now this extraction method, we call it as drafting. Okay, extraction method, we call it as drafting. This is one of the module in any of the softwares that is there in SolidWorks, CATIA, ProE or Creo or Unigraphics. Okay, this is what we do. So this step, drafting, is initially done in wireframe modeling. That is a basic difference. Try to get my point. Now here this drafting is done initially, irrespective of the sketcher, irrespective of the 3D model. They'll try to draw these views, they'll try to draw this front, top and side view just by taking an entity called line or a rectangle. Simply they'll go to the graphic window, they'll take a line, they'll try to start drawing a sketch of this box size and give dimensions, each and every individual view followed by all the dimensions or whatever the tolerances required, they'll try to place it. Okay, now this document is authenticated because I have a proof. I have started at my sketch level where I have given all the dimensions, tolerances, and I have transformed that into a 3D model by using a feature called extrusion. I got this 3D model. Okay, now this 3D model, if I draft it, automatically I'll get all the views followed by all the dimensions given in the sketch level. Okay, so there is an authentication for this, there is a documentation for this, there is a communication, proper communication for this. Whereas in case of wireframe modeling, we'll directly arrive to this solution. We'll directly arrive to this particular solution. Okay, that is a problem actually. Okay, where manipulations are very much possible. You can make your changes. Shape remains the same, but you can change your dimensions. That is possible in this case. Okay, that is the main disadvantage. If you talk about the disadvantages. Other than this, if I talk about the advantages, it will take less storage space. It will take very less storage space of your computer, very less storage space, and retrieving is very much possible and effective. You can retrieve from the database, you can make changes again, fed it back to the system. These are all very much possible things. Okay, and is easy to construct. Fine, this is the thing. So that is the reason initially I said it is not the complete representation, where you can't calculate these things and you can't arrive automatically onto the drafting sheet. Okay, this is the thing. But this is the simplest form of drawing and most confusing. Simplest form, this is the simplest form of, but confusing, because if you find too many edges, for example, if I draw a simple sketch of this kind, there is a sketch. Okay, if I transform it into a 3D model. Okay, now if I consider these edges also, this edge is connecting with this, again with this. Now here get a confusion, you'll get a confusion that which is the front edge, which is the back edge. Okay, so in case of wireframe modeling, we'll consider vertices. If I consider this point as V1, next is V2, V3, V4, V5, V6, 7, 8, 9, 10. Okay, now I can show my wireframe model in the form of 12 vertices from 1 till V12. That is information I could give related to this particular component, where I don't have any surfaces, everything is open. Now you could see from one side to the other, only a wire is winded based on the edges. It is a feel of that kind. So that is the reason you can't calculate them all. So there are few advantages, few disadvantages. So small scale industry, you need to produce a drawing to the shop floor for manufacturing. For them, simple drawing, because they need to produce simple components which are used in day-to-day life. So maybe some machinery, small components like bearing, maybe hexagonal nut bolt or something. So in such cases, they'll try to use wireframe modeling for their design purpose to draw and show it to the shop floor person. Okay, that is the main thing. And one more thing is, wireframe is related to the fact that one may imagine a wire, as I am talking about, one may imagine a wire and is related to, that is bent to follow. For example, if I start at V1, we can imagine that if it is bent to follow the object edges, it is bent to follow the object edges to generate a model. Okay, this is general definition what you call. Okay, you can imagine that it is bent to follow the object edges to form a model, actual model. Okay, so this wireframe model consists entirely of points, lines, arcs or circles, etc. Okay, line nothing but a simple line starting at one point ending at other. There might be a point, there might be a circle, or else an arc, 3-point or a 2-point and a radius, etc. Okay, it is a combination of all this. Maybe a conic or a curve. You can consider a spline also. You can consider spline is represented something like this with a few control points over it. Okay, combination, by using these entities you can create your model, ultimate model, whichever is required. Fine, this is the thing. Now this wireframe model is a common technique used commercially in all wireframe based industries or wireframe based softwares. Now all existing commercial softwares are based on wireframe only, most of them. Okay, If you talk about the advantages, these are the advantages, and it will take the very less time of your CPU. Many things you can discuss. Other than this, wireframe consists of these entities. Other than these entities, if you talk about the advancement in this, there are few more entities got added, wireframe entities. Now this basic wireframe is classified into two types. Number one is analytic type. Number two, synthetic. These are the two methods. Okay, these are two different ways to develop a wireframe model. Okay, now if you consider analytic entities, now as I discussed about line, point, arc, circle, fillets, chamfers and conics, parabolas, hyperbolas, all other things comes under this analytic type. All these you can consider parabola, hyperbola also. If I talk about the synthetic entities, this includes cubic spline, Bezier curves and B splines. Okay, these are the types. Okay, there is a difference between each and every curve. These are the synthetic curves. Now these curves will help you in many ways. For example, if you need to construct a body, car aesthetic appearance, body of a car which should look with number of curves and number of smooth curves with number of radiuses, then we'll try to go with synthetic type of modeling. Okay, now here there is a difference. If you consider a Bezier curve and B-spline curve, there is a difference between both. For example, Bezier curve is a approximation curve, what you call, where if I have some control point 1, 2, 3, 4, 5, 6, some 7 and 8. If I have these many number of control points which is starting at P0 ending at Pn, okay, these many control points. Now in case of Bezier, if I consider a Bezier curve, the curve will not pass through all the control points. It will not pass through all the control points. Okay, it will not pass through all the control points. It passes approximately. Okay, it may miss few. Bezier curve. Now here again the curve can be controlled by using any of the control point it is passing through. If I consider B-spline, if I have number of control points, something like this, again Bezier can pass through all the control points. It can pass through all the control points. So that is the reason we call Bezier curve has an option. B-spline has an option like it can be used in case of approximation like Bezier, as well as now this consider if we consider this as the curve, it is passing through all the control points. Now this can be considered as interpolation type. Okay, now Bezier is an approximation curve, whereas B-spline is approximation as well as interpolation type of curve, used for both of them. Okay, now this type of curvilinear structures can be made by using this particular wireframe modeling. Okay, now this wireframe model again a base for the surface modeling to develop, because in case of wireframe modeling we'll use entities and it need to be bent, the wire need to be bent with respect to the edge of the model to get the required shape. Whereas in case of surface modeling, surface has to be generated by using this Bezier curve or B-spline curve. In such cases, wireframe becomes a base for the surface modeling. Fine. Now if you talk about the input coordinates, if you talk about the coordinate system of wireframe modeling, coordinate system of input coordinates, you can give inputs in three different ways, like one is Cartesian and one more is cylindrical and one more is spherical. Okay, all the three are different from each other. Now here we consider the coordinate as x, y, z, whereas in this case we consider it as theta, z, whereas in case of spherical we consider it as r, theta, phi. Okay, this is about an wireframe model. For example, if I consider a wireframe model of this kind, for example there is a model of this kind. If I try to cut the model from top to bottom horizontally, if I try to cut them, okay, from top to bottom, now this portion removed and this will remain. Now if I look at the remained portion, the cross section, the view is going to be something like this. I could see only 4 dots because all the 4 are wires that has cutted from top to bottom. Now I could see a wire. Okay, this is the cross section of wireframe modeling. If I consider this box as a surface model, second one, surface model, if I cut from top to bottom, the cross section of surface is going to be something like this, cross section of surface. Okay, if I cut the same model, if it is a solid again, if I cut it from the top to bottom, the solid cross section is going to be something like this. There should be a hatching. This is a cross section of solid. Okay, here you can understand now easily. If I cut the model, if it is a wireframe made of wireframe, the view is going to be something like this. I could see all the 4 dots, whereas in case of surface I could see okay, there won't be any internal things I'll show, and here in case of solid will hatch the model. There is a main difference. Okay, the cutted portion need to be hatched in case of solid, that we could know easily. Okay, this is the difference between a wireframe model and a simple surface modeling. Okay, again, now this is the most important thing, approximation curve and interpolation curve. Now coming to the surface modeling, if you talk about the surface modeling, now consider a box. Similar case, consider a box. Now this box has to be created in surface modeling by different phases. Okay, I'll consider this as surface 1, this as surface 2, surface 3, and bottom one surface 4, left side one surface 5, back side surface 6. If I consider or if I construct 6 surfaces, I could get this shape. 6 surfaces of same size, I could achieve or arrive to this particular solution or a model. Okay, whereas in case of solid modeling, if I want to develop a same box, I need to create a sketch of this size by this size, or this width by this width. Okay, so I can extrude the model. That is the only difference, where you get the volume actually. Now here with these sketches, you can easily understand what is wireframe model, what is surface model, and what is solid model. Now as I said, wireframe is not a complete representation. Solid model is a complete representation of that particular component, where you can find the mass, you can find inertia, you can analyze the model. Even surface modeling is not a complete representation in some cases. Okay, now surface forms the base for solid modeling. Again, surface modeling are also many types. There are plane surfaces, ruled surfaces, surface of revolutions. Okay, now this cubic spline, Bezier curve, B splines, they have given, we need to consider few equations to get this particular parametric curves. We need to consider few equations. In case of cubic spline, if you consider the first one, cubic spline, Hermite cubic spline, the equation is something like that. P of u is equal to sigma I is equal to 0 to 3 followed by C suffix I U suffix I. Okay, where u acts as a parameter and Ci acts as a polynomial coefficient. Okay, this is the equation given. Okay, with this equation we will get this particular Hermite cubic spline. Sigma I is equal to 0 to 3, C suffix I, U suffix I, and u is a parameter and C is a polynomial coefficient. This is for cubic spline. If you consider Bezier, again for Bezier also there is an equation given. P of u is equal to sigma I is equal to 0 to n followed by pi. In both the cases 0 less than or equal to u less than or equal to 1. Okay, this is the equation for cubic spline. This is the equation for Bezier curve. Okay, P of u is equal to sigma I is equal to 0 to n pi bi suffix b suffix I comma n of u, where here in this case P of u is any point on the curve. Okay, pi is a control point and bi suffix I comma n is a polynomial which serves as basis function. This is a polynomial actually, polynomial which acts as a basis function for the Bezier curve. Okay, this is the main reason to develop a Bezier curve. Fine. Now we'll consider a curve for B spline also. Now in case of B spline, the equation is almost similar. P of u is equal to sigma I is equal to 0 to n, I is equal to 0 to n, and p suffix I comma n suffix I. This is the equation given, comma k of u, p suffix I comma n suffix I comma k of u. Now in this case also 0 ranges, the range is 0 less than or equal to u less than or equal to u. Okay, there we consider 1, here we consider maximum. Okay, these are 3 equations need to be remembered when somebody asks you to define in part A, maybe in part B. If they ask you to define, you need to define these curves with the help of this approximation level or interpolation level followed by an equation. Okay, that's it for now. This is all about wireframe modeling, and in the second part of geometrical modeling we'll discuss about surface modeling, and in third part we'll have a discussion on solid modeling. Thank you for now.